In this video today, we'll discuss about work done in an adiabatic process. Work done in adiabatic process. So first of all, let us discuss what is the adiabatic process. Adiabatic process means here heat exchange is allowed, not allowed with the surrounding. Suppose this is a system and this is your piston. This piston can move up and down. Now the wall is adiabatic. That means here heat exchange is not possible. The outside heat or the surrounding heat cannot go inside. The inside heat also cannot go outside. Heat exchange is not possible. So that means if I'll compress this piston downward, then its volume will decrease and the temperature will increase. If I'll expand this, the volume will increase and the temperature will decrease, cool down. It will be the process of cooling. Okay, so compression will increase the temperature and expansion will reduce the temperature. Now at least we understood what is the adiabatic process. Now let us calculate the work done in this process. So work done is PdV. Integration PdV means we are in summing up small all the small work done, and together we are getting the work done, the total work done. So let's say the V1 expansion is from V1 to V2. Now for adiabatic expansion, for an ideal gas, for an ideal gas, adiabatic expansion having adiabatic expansion without proof. I am writing in my other video. You can see the proof of P, this expression P v to the power gamma is equal to constant. P v to the power gamma is equal to constant. So this is for adiabatic expansion. Okay, what is gamma? This gamma is equal to Cp by Cv. Specific heat capacity at constant pressure divided by specific heat capacity at constant volume. So this will be valid for an ideal gas, and if it is in exhibiting the adiabatic, undergoing the adiabatic expansion. So here in place of P, what I can write? P I can write that it is constant by v to the power gamma and dv integration from v1 to v2. Now k I'll take outside, and v to the power gamma I can write v to the power gamma minus gamma, because it was in the denominator. I have taken to numerator, v1 to v2, k. The formula I'll use our old formula, that x to the power n dx integration is x to the power n plus 1 by n plus 1. So this formula I'll use here. Here power is minus gamma, so you can use this formula here. So this one will become v to the power minus gamma plus 1 by minus gamma plus 1 and integration v1 to v2. Then k, this is v to the power 1 minus gamma divided by 1 minus gamma v2 minus B1 1 minus gamma by 1 minus gamma. Then if I will simplify more, then K into by 1 minus gamma, this is gamma, into I want to write in this form, that is V2, acha, K V2 1 minus gamma minus K V1 1 minus K I multiplied and take 2 inside the bracket. So K I can replace with PV to the power gamma. So I will write 1 minus gamma. K I will write, this is V2, so I'll write V2 and V2 to the power 1 minus gamma. Minus this is B1, so I can write B1 to the power gamma. I replaced K and B1 1 minus gamma. So here you can write 1 minus gamma minus 1. I have taken 1 minus common, so I will take it to inside. So it will become, this one will become plus and this one will become minus. This step in the last step, because I have changed the gamma minus 1, I have made it. So this one will become your this is 1 minus gamma, so minus gamma plus gamma ये कट जाएगा, to cancel out. So P2 V2 my ये minus common निकले हो, P1 V1 which will be equal to 1 by gamma minus 1 PV P1 V1 is equal to mu r T1. So mu r I am taking outside, T1 minus T2, because this minus I have multiplied inside and it becomes P1 V1 minus P2 V2. So one term comes first, then second term. So the work done we got, the final expression we got is work done is equal to mu r by gamma minus 1 T1 minus T2. So this is the work done we got for the adiabatic case. And in this case also you can see that if compression is taking place or work is done on the gas, then what will happen? The volume will decrease and temperature will increase. Okay, that means your T2 will be greater than T1. Similarly, if the work is done by the gas, expansion will be there and temperature will decrease. So T1 is greater than T2. Final temperature will be less than initial temperature. That means T2 will be greater than T1. So you can write one note or conclusion that for expansion, T2 is less than T1 and compression T2 is greater than T1. Expansion means work done by the gas. Compression means work done on the gas. That means you will compress, piston will go down. Okay. So this is what the work done, and it will be used in the Carnot cycle and also in other processes where the adiabatic process is involved. You can use this result of this work done. Okay. I hope it is clear. If you find any difficulties in any step, then you can write in the comment box. I can make another clarification video for the doubts. Thank you for watching the video.